The next category of operator is bitwise operators. As the name suggests, all the bitwise operators operate at the bit level. There are 6 of them: bitwise AND, bitwise OR, bitwise exclusive OR, also known as bitwise OR, bitwise NOT, bitwise left shift and bitwise right shift operators. All of them operate on integers by interpreting them as patterns of bits and generate a new pattern of bit based upon the input bit patterns and the operator. The functioning of the first 3 operators, bitwise AND, bitwise OR and bitwise OR, is very similar. All 3 are binary operators, which means they require 2 operands to work with. This is the general format of their application. These operators compare each bit of the left and right hand side operand and generate a new bit corresponding to each comparison, which depend upon the bits being compared and the operand. The bit generated by the bitwise AND operator is 1 if both the bits being compared is 1 and 0 otherwise. And the bit generated by the bitwise OR operator is 1 if any one bit or both the bit of the bits being compared are 1. Whereas the bit generated by the bitwise OR operator is 1 if exactly one bit of the bits being compared is 1. Let us understand the application of these operands through example. This code sample applies the bitwise AND operator over 38 and 42 and prints the result. If you run this code sample, you will observe 34 getting printed on the terminal. In order to understand the reason for this output, we need to analyze the bitwise AND operation at the bit level. The binary representation of 38 and 42 are, respectively, when applied, the bitwise AND operator will compare the individual bits of the 2 given bit patterns starting from the least significant bit, which is the rightmost bit. It has been mentioned that the bitwise AND operator will generate 1 if both the bits being compared are 1, otherwise it will generate 0. The least significant bits of both the bit pattern is 0 and hence the operator will generate 0. The second least significant bit of both the bit pattern is 1 and hence the AND operator will generate 1. The third least significant bit is 1 and 0 respectively and the AND operator will again generate 0. After comparing each bits of the input bit patterns in a similar manner, the AND operator will generate the following bit pattern. The decimal equivalent of this bit pattern is 34 and this is what you saw get it printing on the terminal. Let us use the same example to understand the functioning of bitwise OR operator. This code sample applies bitwise OR operator on 38 and 42 and prints the result. In this case, you will see 46 getting printed on the terminal. Bitwise OR operator works more or less the same way as the bitwise AND operator works. It compares the individual bits of both the operands and will generate a bit based upon the bits being compared. Let us dive at the bit level to understand the reason behind the output. It was already mentioned that the bitwise OR operator generates 1 if at least one of the 2 bits being compared is 1. This is the bit pattern of 38 and 42. The least significant bit in both the operand is 0 and hence the OR operator will generate 0. The second least significant bit in both the operand is 1 and hence the OR operator will generate 1. The third least significant bit is 1 in 38 and 0 in 42 and hence the OR operator will generate 1 in this case. Finally, after comparing each bit of the input bit pattern, the bitwise OR operator will generate this bit pattern. The decimal equivalent of this bit pattern is 46. This is what was printed by the print statement in our code sample. The working of the bitwise OR operator is very similar to the working of the bitwise AND and bitwise OR operator. Let us straight away jump to an example. This piece of code applies the bitwise OR operator over 38 and 42. The output of the print statement will be 12. Like the previous two operators, OR operator compares each bit of the left and right hand side operands and generate 1 or 0 depending upon the bits being compared. It was mentioned earlier that the bitwise OR operator generates 1 if exactly one bit of the two bits being compared is 1, otherwise it generates 0. This is the bit pattern of the 38 and 42. Since the least significant bit of both the bit patterns are 0, the XOR operator generates 0. The second least significant bit in both the bit patterns is 1 and hence the XOR operator will generate 0 again. The third least significant bit is 1 in the bit pattern of 38 whereas it is 0 in the bit pattern of 42. So the XOR operator in this case will generate 1. After comparing all the bits of both the bit patterns, the generated bit pattern will be this. You are requested to repeat the above exercise for all the bits and verify the result. The binary equivalent of this number is 12. And this is what was the number we obtained in the code sample. We have discussed with examples the functioning of bitwise AND, OR and XOR operators. It was observed that the functioning of all of them is very similar. All of them compare the individual bit of the operand and generate a new sequence of bits depending upon the bits being compared and the operator. The next bitwise operator is to be discussed is Bitwise Not Operator. It is a unary operator, which means it will require only one operand to perform. This is the general format of its application. Like other bitwise operators discussed so far, this operator also works with the bits of the operand. This operator works by examining each bit of the given bit sequence and generate a bit which is the opposite of the bit being examined. Let us understand this through an example. In this code sample, the bitwise not operator has been applied over 38. The output of the print statement will be -39. Analysis at the bit level will help you understand the reason behind the output. The binary representation of 38 is this. The bitwise not operator will start from the least significant bit. The least significant bit in this bit pattern is 0 and hence the not operator will generate 1, which is the opposite of 0. The second least significant bit of this bit pattern is 1 and hence the not operator will generate 0, which is opposite of 1. The final bit pattern generated by the bitwise not operator is this. Since the most significant bit in this bit pattern is 1, this number will be interpreted as a negative number in 2's complement notation. This notation and the interconversion between decimal and binary representation is covered in the video about variables. You may refer to it if required. The decimal equivalent of this bit pattern is -39, which was the output of the print statement seen earlier. You are advised to try the piece of code mentioned earlier and verify the output yourself.